I don't know. Ooh. Because fabulous. I wrote this generic example because I feel like this might help a bit. Basically, first thing first, we will check if we can multiply the two matrices. So, number of columns of the first matrix, so the second number, and the first number, so the number of rows of the second matrix. Those are equal, so we can multiply them. Second thing, 4 by 3 is the dimension of the solution. At this point, we will call this A by B. We will call it C equal to, oopsie, I think it's too big. Anyway, we will not write all the entries. We will only do this. 1, 2, 3, 4, because we know that we will have 4 rows and 3 columns. 1, 2, 3. Okay. Now let's take as an example this spot here. This spot will be, for example, C. Let's say C11, and this will be C12. Okay. And we will compute this. We will compute this using this formula. In this case, this spot right here will be obtained by first row. This is the first row. And second column, second. We will have that A 1, 1 by B 1, 2 plus A 1, 2 by B 2, 2. The summation is R equal to 1 because it's still 1. R goes from 1 to N. N is, in this case, N is 2. So we know that R, here and here, has to move from 1 to 2. 2. Okay? And following the summation, we will know that it starts here from 1 and then it goes to 2. So, as we said, we are multiplying A by B with the, well, yes, the first position of R. And then we are summing, because this is a sum, A multiplied by B with R that goes to 2. I think that it sounds way more complicated than it is. I'd rather just visualize what I'm gonna do. And for example, if I want to find this spot right here, I just know that I will use this row and this column of B. We are 1, 2, 3, 1, 2, 3, and 1, 2, 3, 1, 2, 3. So I already know that I will do that, and I just prefer to visualize the thing and use this way of computing the matrix. Of course, it is also important to understand the formulas. So if we had a 4 by 3 matrix and a 3 by 3, we would have that n would be equal to 3. So up here we would have 3. In this formula, there's nothing that's new. You just have to link all the elements of a formula with what you already know, what you already have. If you're more comfortable with the formula, you can use the formula. Just to finish this example, let's also do this and write it down. So we will have that R1 always 2, and the formula can be written as A3 1 by B 1 3. Now we sum because it's still a sum, and A3 2 by B 2 3. If it was 3 here and here, so 4 by 3 and 3 by 3, we would also have obviously another number here and another number here. You would have another plus and other elements. Hope that was clear. I mean, everything is clear in my mind, but I don't know if I'm expressing that correctly or just making it worse. This is a 4 by 3 and this is a 3 by 4. Okay, so yes, we can multiply them. Same number of columns, same number of rows, 3, 3. And the solution is 4 by 4. Let's call this C. And goodbye. A bit better. I'm only going to write the first entry using the formula. This right here. C11 is equal to, okay, let's also use this notation that we mentioned earlier. We will use the first row and the first column, right? So we can also write, because as we saw, using the number here refers to the row of this matrix, and using the number here you refer to the column. So this is the first row and the first column, and in this case is 3. Our summation will go from 1 to 3. A11 by B11 plus A12 by B21. Sorry, this one. B21 plus A13, this, by B31. A11 is 1, can you see? Yes. 1 by 3 plus 1 by 0 plus 0 by 4. We will have 3. N is 3, and we have 3 elements that we're going to sum. If we want to find this one, we are in the first row, so we will use the first row, but second column, so second column. So we will have 1 by 0, 0, 1 by 1, 1. So this is 1.
Then first row, so always here, that third column, this one by this one. So minus 1, minus 2, 0. So minus 3. First row, last column, first row, last column. So minus 2, minus 1, minus 3.
Second row, so let's start with this, and first column, this. Minus 6, 0, 4. So minus 2. Second row, so always here, second column, 0, 3, 1. So 4.
Second row, third column, here, minus plus 2, minus 6, so minus 4. Second row, last column, 4, minus 3, and 2, 3.
I haven't done the whole procedure because it was gonna be pretty long. I mean, not pretty long, but I'm gonna cut that off. So this is the final solution. It is a 4 by 4 as we saw earlier. This is a bonus special case. So it's the case of vectors.
Here we have a row vector, and here we have a column vector.
As we can see, it's possible to multiply them, but when we multiply them, the solution will be a scalar. So the solution of a multiplication of a row vector and a column vector is a number. By u equal to row vector v1n and u11, u21, and so on until n1. All you do is summing all of them. For example, we have 1 by u 1 by 1 plus v12 by u21, and so on until we arrive 1n by u and 1. So this is one sum, which means that the solution will be a number, a scalar k. Let's call it k as usual. This is especially useful because in physics you use all the time vectors, so this is the very basic case for physics. Last but not least, let's talk about the rules, aka the properties, and the first one is my favorite one because I still don't know how to pronounce it, and it would be associativity. Yeah, not gonna happen, but at least I know how to write it. Yeah, the three matrices, let's say A, that belongs to M and N, B that belongs to N and L, and C that belongs to L, K. I don't know, I'm just gonna go with the flow and let's say LK. The important thing is that we have to make sure that this is equal to that and this is equal to this, because these two are gonna be related and these two are together. This is very important because of, I mean, the order here is important, as we will see with the last property, but it is important. So A has to be compatible with B when we want to multiply them, and B has to be compatible with C. C is equal to A, B, C. So easy, common, we've seen this a lot. That's it. Second one, distributivity of the sum with respect to the product. This is also something you might see in scientific papers, and it means with respect to. So just gonna throw in also that one. We have that, let's consider again this case. We have that A plus B multiplied by C is equal to C plus B. C. Last one is mixed associativity. Again, consider this case, and we will have that A that multiplies a scalar. We can also use K, it's still scalar. Multiplies B is equal to A by B. Okay. Something that I mentioned here, and that it's really, really, really important, is that the multiplication of matrices it's not commutative. So that doesn't apply. These are not the same. There are specific cases where these can apply, but mostly it doesn't. So you cannot just switch two matrices and expect the same solution. I might give an example, but I think I'm running late. So this is it, I think. I'm done with the matrix multiplication. I'm done with properties. I'm done with everything. No, just kidding. But I will be back next time, and I have a schedule, different types of matrices, and I will talk about the trace of a matrix. So let's see you next time. I think it will be next Sunday. I'm trying to keep it that way, like uploading a video on Sunday. Thank you for sticking with me, and I hope I was at least a bit clear. Thank you, and see you soon.